Hello, welcome back. In this segment, I will prove that the set bad is contained in the set bad prime. I will define bad prime shortly, but here is the structure that we have been looking into. Zn star is our group. We assumed that n is an odd number, otherwise it's easy to test whether n is a prime or not. We also assumed that n is not a power of some other number. If n is a power of some other number, there are polynomial time algorithms to detect that. Therefore, n cannot be a prime number. Since n is odd, n minus 1 is an even number. So all even numbers can be written as 2 power r times u. I have shown you an algorithm how to do that. R must be greater than or equal to 1. And u must be an odd number. We will write n minus 1 as 2 power r times u. U being an odd number, r can be greater than or equal to 1. Okay. All right. So what is bad? Bad is a set of all elements in the group Z star n that are not a strong witness. Okay, meaning if you take any element from the bad set, like if you take a point here, it will violate the strong witness property. What is a strong witness property again? We talked about it earlier. An element A is a strong witness for n being composite if a power u is not equal to plus or minus 1 and a power 2u, a power 2 square u, all the way until a power 2 power r minus 1 u is not equal to minus 1. Okay, this is the property of being a strong witness. I proved that if n is prime, there cannot exist a strong witness. That means if you find a strong witness, n has to be composite, right? That's the idea we have been following so far. All right, so now question now is to figure out the size of the bad set. How big is the bad set? Okay. Minus 1 is an element in bad because if you take minus 1 and raise it to power u, what is the value of minus 1 power u? Since u is an odd number, minus 1 power u will be minus 1, which means, as you can see here, if you put a equal to minus 1 power u turned out to be minus 1. Minus 1 not equal to minus 1 is wrong. That means minus 1 is a bad element. So minus 1 does belong to bad set. Okay, that's an interesting first fact. Minus 1 is a member of bad. Okay, and given that, let's think about finding an I such that a power 2 power I times u is equal to minus 1. Okay, find the largest I such that this equation is true. Okay, this constraint is true. Will such an I exist? Obviously, it will exist, because if you put I equal to 0, for example, and a to be minus 1, we have shown that minus 1 is equal to minus 1 here. Minus 1 power u is equal to minus 1. Okay, therefore, such an I must exist. Okay, so we are going to limit the I between the range. This is nothing but 2 power I. This is nothing but 2 power 0, right? From 0 through all the way to r minus 1. Okay, such an I must exist. Okay, this is clear. Such an I must exist. Now it's time to define bad prime. Bad prime contains set of all elements in Zn star such that set of all A such that a power 2 power I, we are still in the power, times u in the power is equal to plus or minus 1 in mod n. Everything is mod n here. Okay, so I'm not writing mod n again and again. Is equal to mod n, 1 in mod n. Okay, so here is the bad prime definition. And now we need to show the set bad of all bad witnesses will be contained in another set called bad prime. Okay, how do we do that? In order to prove this, one set is contained in another set, we can take an arbitrary element in one set, right? Take an element A in bad and show that A also belongs to bad prime. Okay. Take an element A from bad. What does it tell us? It is telling us that either a power u is equal to plus or minus 1, right? Or a power 2 power some power of 2 times u is equal to -1. Otherwise, a will be considered as a witness, right? So that is basically the reason why we say a belongs to bad. This property must be violated. Okay, it cannot be a strong witness. Okay, that's basically the definition of an element A belongs to bad. Okay, so more formally, we take an element A in bad. Okay, let's take A in bad and prove that it will be part of bad prime. All right, let's get it going. Since A belongs to bad, what can we say? We can apply the definition of bad, right? That means either a power 2 power j times u must be equal to -1, or a power u is equal to +1. Okay, this is just coming straight from the definition of what does it mean, what is the meaning of a bad set. Okay, it's an opposite of the strong witness. Okay, it's just +1. And what is the value of j now? J can be 0 or 1 or 2 all the way until r -1. So j belongs to the set 0, 1 all the way until r -1. All right, we took an a in bad and we wanted to show that a belongs to bad prime, right? And I'm going to consider a power u is equal to 1 scenario. A power u is equal to +1. Okay, what does this imply? This implies that a belongs to bad prime also, because power 2 power I. Okay, but what is a power u? A power u is 1. Therefore, we proved that a also belongs to bad, and we proved that it also belongs to bad prime. So this implies a belongs to bad prime. The case 2 is a power 2 power j times u is equal to -1 for some j, okay, between 0 through r -1. 2 power j times u is equal to -1. What can we say about j and I? Remember, I is the largest value such that a power 2 power I times u is equal to -1. That means j must be less than or equal to I. Okay, this implies j is less than or equal to I. Okay, if j is equal to I, the case is simple, right? We just replace j by I, then we have shown our a also belongs to bad prime. Let's consider the case that j is not equal to I. In that case, how do we rewrite a power 2 power I? We write a power 2 power I times u as a power 2 power j. I introduce j here, this is j, times u, and then I power this whole thing again with 2 power I minus j. Okay, this means that my I have introduced a j here, right? So I have to subtract the j. That means when I multiply, the powers will add and j will go away. Okay, so what about a power 2 power j times u? We know that it's -1. This is because a belongs to bad. Therefore, we can say this is nothing but 1, because we have a -1 here. This is -1, and -1 power of an even number is always 1. Okay, so what did we prove? We proved that we in both cases, the case 1, a power u equal to 1, a belongs to bad prime. In the case that a power 2 power j times u is equal to -1, we also proved that a belongs to bad prime. So we proved both cases. Okay,